All right, here we are with example 4. Uh, Exercise 6 that you're going to do in a minute is pretty similar to example 4. So pay attention to this so you know how to do exercise 6 yourself so you can get that practice. So this one says to write each one of these expressions in terms of log x and log y, or state that this is not possible. So what we want to do is see, can we apply a log law to this expression? So the log laws are these three things. I'm going to call this log law 1, log law 2, and log law 3 here. So is there, which log law applies to this? Well, this looks like we have a fraction inside the log. It's like log of a over b. So you can use log law 2 to turn this into log of a minus log of b, which is log of 100 minus log of xy in this case. And then log of xy, we can simplify that, or write it differently in terms of log x and log y using log law 1. So this would become, instead of a and b, we just have x and y. So this is going to turn into log of 100. Oh, which, by the way, what's log of 100? Let's do that too. What is the exponent of 10 that results in 100? That is 2. So log of 100 is just 2. And then we have minus this whole thing here. So that whole thing is going to turn into log of x plus log of y. But careful, because if we're subtracting this whole thing, the way this is written right now, you'd just be doing 2 minus log of x, but then plus log of y. So to show that you're subtracting the whole thing, we need to put parentheses around that. And if you want to write it without the parentheses, you can distribute that minus in there and write it as 2 minus log of x, and then that minus log of y. Either of these is okay. So that's what we mean by write it in terms of log x and log y. This is an expression that has log x and log y in it, but it doesn't have like a bigger combined logarithm. Okay, so that's that. I'm going to scooch that over to make some room for b here. So let's see. If you want to see what log law applies to this, you got to be careful. It looks kind of like log law 3, doesn't it? Like where you have something to a power, where the power is, instead of t, we have 3 here. But that's not exactly what this is, because it's not just something to a power. That 3 doesn't apply to the whole thing. If there were like extra parentheses in here, and it was log of this whole thing to the power 3, then in that case, this would work just fine. But that's not what this is. It's just the y to the power 3, and then these other things are being multiplied. So when you have things being multiplied inside a logarithm, then the one you have to use is log law 1. So this is going to turn into log of 0.1 plus log of x plus log of y cubed, using log law 1 here, that says when they're multiplied inside the input into the logarithm, you can separate them out into separate logs here. So then these things we can simplify individually. Log of 0.1, that's the exponent of 10 that results in 0.1. The exponent of 10 that results in 0.1 is negative 1. So that is negative 1. We have log of x, that's already simplified enough. And then now, this log of y cubed, now the thing inside the logarithm is just something to a power. So we can use that now. And what this says to do is to take the exponent t, and you can write it on the outside and multiply it by that result afterwards. So that's a 3 here. We're going to write this as 3 times log of y. And that's that one. Okay, so how about this one? This one is now written as log of something all to a power. This one you can use log law 3 with. It's just instead of b, we have 0.1 xy in there. So I'm going to use log law 3 here to turn this into 3 times log of 0.1 times xy. And then that logarithm you can now use log law 1 with. So that's going to turn into, I'm running out of room here, 3 times this whole thing, I'm going to need parentheses around it, log of 0.1 plus log of x plus log of y. I need the parentheses because remember you have 3 times this whole thing here, so all of this should be multiplied by 3. If you don't have these parentheses, it looks like you're just multiplying just the 3 times this part, which is not quite right. So that needs parentheses. And then log of 0.1 is still -1. So this is going to be 3 times -1, which gives you -3, and you can distribute the 3 into the rest of this. So that is that result. So let's see. Yeah, so just notice the difference between these. Like, the thing inside the logarithm for b really is the result of multiplying 3 things. And one of those 3 things happens to have an exponent. Whereas for c, the thing inside the logarithm is all to a power. All right, so now let's look at this one. Log of x plus y inside the logarithm. Let's look at the log laws and see what applies to it. The x plus y here, that's the input into the logarithm. So it's not the same as this thing over here. So it's not going to be log of x times y. It looks like this log of a plus b there, but that's not log of a plus log of b. So you can't turn this into log of x plus log of y. That's a really common mistake because it looks like the distributive rule. But there is no distributive rule for logarithms. That is a log gnaw. So this is not possible. This can't be simplified. Or Alright, so there's a lot of things about logarithms here you can see are kind of unintuitive. Like, you want to turn this into log of x plus log of y, but you can't. And yeah, there's a lot of little things to be careful of. So this is, like I said, a pretty tricky section. Okay, so now exercise 6, you got some examples that are very similar to example 4 here. Let's pause it for a moment while I whistle, and then after you've tried them, come back and check your answers. Okay, so this is a log of a fraction. So you can use log law 2 with that. Right, this is log of x squared minus log of 10. Log of x squared this is log of something to a power. The power is 2. You can use log law 3 with that. That will turn into 2 times log of x. And log of 10 is always going to be equal to 1, because the exponent of 10 that results in 10 is 1. So that's that. B, you can't do anything with. There's no log law that has them separated as separate terms inside the logarithm. C here, let's see. Let's notice the difference between C and D. Which one of these is written as a logarithm of two things being multiplied, and which is the result of a logarithm of something to a power? This one is the result of multiplying two things, x and y cubed, and this one is the result of doing something to a power. So log law 1 applies to C here. This should turn into log of x plus log of y to the power 3. And now, with that one, you can use log law 3 and take that exponent 3 and write it as multiplication in front of it. And you get that. Now with this one, log law 3 is the one that applies to this one first. So that's going to be 3 times log of xy. And then log of xy is going to become log of x plus log of y. So you could distribute the 3 in there if you want. And that's what you get. So you notice, like with this one, the idea is that the 3 applies to the x and the y. Both of them have the exponent 3 on them. So in the end, you end up with a 3 getting multiplied by both of the logarithms. With this one, you only have the 3 applied to just the y, so you end up with a 3 just multiplied by that. So, exercise 7. You got some equations to solve. These might be tricky. I recommend trying them just because you'll learn something that way. If you get stuck, that is absolutely okay. So starting with exercise 7, the trick here is that 10 to the power x equals 2 equals 0.2. This means the same thing as saying log of 0.2 is x. And that's basically the solution. You could just write it like that. That's a number, log of 0.2. You probably want to get it as a decimal, which is negative 0.69897. And that's that. So again, that's what a logarithm does. You swap the output of the exponent and the input of the exponent. They become the output of the logarithm and the input of the logarithm, respectively. And that gives you an equation where x is just the result. So, yeah. So how about with this one? Let's get it so that we have something in the form of just log of something equals something. And I'm just writing this for reference. This is the all-important definition of what a logarithm is. So to get it, so we have something that looks like this, like I was saying, we want to get the logarithm by itself. So you can divide both sides by 2, and you'll get log of x equals 5 over 2 is 2.5. Now, if you have it looking like this, and you want to get rid of that logarithm, you can just write it in the other format here, which is log of x equals 2.5 means that 2.5 is the exponent of 10 that results in x. 10 to the 2.5 is somewhere between 100 and 1,000. Let's see. $316.23 about. Okay. Now this one is kind of like this equation we had here. We have log of something equals a number. Here we have log of something equals a number. It's just that instead of just x, we have x plus 400. We can still do the same thing as this. It's just going to be x plus 400 is the result of doing 10 to the power 3. So I subtract 400 from both sides of this. 10 to the power 3 is 1,000. So we're doing 1,000 minus 400 is 600 is equal to x. And that's the solution there. And all of these, by the way, it's a good idea to check them with your calculator. I always recommend checking things with a calculator because it not only makes sure you get the right answer, but it also helps you understand why the methods you're doing work. So if we do log of 600 plus 400, that's going to be log of 1,000. That's the same as 10 to the power 3. So the result of that logarithm is 3. Okay, this one has a few more steps. We still want to get something that looks like 10 to a power equals something, or just get the logarithm by itself like we were doing before. So in this case, we want to get 10 to the power by itself. So to do that, you can start by subtracting 4, and you'll get negative 5 times 10 to the power x equals negative 5. Divide both sides by negative 5. You'll get 10 to the power x is 1. And this is one you could solve without a logarithm, maybe. I mean, if you want to write it as a logarithm, that's okay. It would be log of 1 equals x, and the result would be 0. Because 0 is the exponent of 10 that results in 1. All right, E is a tricky one. And the trick here is that all of the numbers, like the 100 and the 10,000 here, those all are powers of 10. So we can actually use the methods of section 6.4, where we try to write it as 10 to a power and 10 to some other power, and try to make those the same. So 100 is 10 to the power 2, right? So I'm just going to replace the 100 with 10 squared. And that's that. And then if I just want to write this as just 10 to a power, if you have a power to a power, you need to multiply those. So this is going to become 10 to the power 2 times 2x plus 3. So that way we just have 10 to a power over here. Now how about 10,000? Let's see, 10,000 is the same as 10 to the power 4. And the cube root is the same as whatever that is to the power 1/3. So yeah, so the cube root here is becoming that to the power 1/3. The 10,000 there is the same as just 10 to the power 4. So now how can you combine these? If you have 10 to the power 4 and then that to the power 1/3, you can multiply those exponents. That will become 10 to the power 4 over 3. So hey, we have 10 to a power equals 10 to a power. So whatever value of x makes those exponents equal is going to solve this equation. It's going to make the two sides of the equation equal. So for the left side, I'm just going to go ahead and distribute that 2 and write that as 4x plus 6 equals 4 over 3. And then you can subtract 6 from both sides. Four thirds minus 6 is going to be oh my gosh, let's work this out. 4 thirds minus 6 over 1. 6 over 1, if I want to make this be times 3, I have a 3 in the bottom. We have 4 thirds minus 18 thirds, which gives you negative 14 thirds. And then we can cancel out the 4x by dividing both sides by 4. And you might want to think of dividing by 4 as times 1/4 here to make it easier to combine these fractions. But dividing by 4 and multiplying by 1/4 are the same thing. So that gets you x equals negative 14/12, or x equals negative 7/6 also works for that. Phew, so that is a tricky one. Congratulations if you got that one. Hopefully you got a few of these on your own. But a good time to work on these to practice your knowledge of logarithms is today, because you're going to need some knowledge of logarithms to understand what's going on in 7.2 when you do that section. So good luck with the quiz on this, and I'll see you in the next video or in office hours. Have a good day.